Welcome to the Deep Dive. Today we're jumping into something that feels like it's straight out of science fiction, but it's very real. A system called AutoOps. And this isn't just about, basic automation. We're talking about full-on autonomous orchestration.
Yeah, that's a good way to put it.
So our mission today is to really get under the hood and figure out how a super complex goal, something that would normally take a whole team of people, can be done with, and this is the kicker, zero human intervention.
It's a fascinating question, and AutoOps is a really compelling answer. It's this fully automated system that can take a goal, actually plan it, do the research, run code.
All of it.
All of it. It analyzes the results, and this is the important part, it evaluates its own work, all without a person needing to click next.
Okay, so the intelligence behind that, the core reasoning, I read that it's powered by Gemini Flash. That's what's doing the heavy lifting, the thinking part.
Yeah. Exactly. You can think of Gemini Flash as the general intelligence. It's the strategist. It understands the complex goal. But then the architecture uses a bunch of specialized agents. They're the doers.
The thinkers and the doers.
Right.
And for the user, this all looks incredibly simple. You just type in what you want, and this whole symphony just starts.
It's almost deceptively simple from the outside.
Okay, so let's unpack that symphony. Because it can't be chaos.
Yeah.
There's a structure, a workflow. What's the thinking behind this modular, multi-agent approach? Why not just one giant AI?
Well, it comes down to specialization and basically not having a single point of failure. AutoOps uses this modular setup where every single agent has one specific job to do.
Like an assembly line.
A perfect analogy. It's like a high-end assembly line for information.
Yeah.
If one tool on that line breaks, you know exactly which one it is, and the whole factory doesn't just grind to a halt.
That makes a lot of sense. So you have the general intelligence from Gemini Flash guiding these very specific specialists. So where does it start? The user gives it a goal, and the first point of contact is the coordinator agent.
Yep. The coordinator agent. It's the maestro, the conductor. The second you submit a goal, the coordinator grabs it, and its job is to manage the entire flow from start to finish.
So the project manager of the whole operation.
You could say that and make sure every task goes to the right agent in the right order.
Okay, so let's trace a task. Let's say I ask to, analyze Q3 earnings for 3 tech companies and give me a competitive summary. Where does the coordinator send that first?
Immediately, it goes to the planner agent.
Planner.
Makes sense.
Its whole job is to take that big, kind of vague goal and use that Gemini reasoning to break it down into small, actionable steps. It turns the mission into a checklist.
Okay, but what if a step is, impossible? Or it needs information the system doesn't have yet? It's not just a rigid sequence, is it? Not at all. It's a dynamic plan. If the planner sees that a step requires, say, the latest stock data, it flags that. And those information gathering tasks get passed immediately to the research agent.
The system's own librarian.
Or a web sleuth, yeah. It just goes out to the web, pulls the data, finds the context it needs.
So plan first, research second. Now we get to the action. If the plan involves running some calculations on that earnings data, that's where the executor agent comes in. And this is where we have to talk about safety.
Yes, this is absolutely critical. You can't just have an autonomous system running code on its own.
Right.
So the source material makes a huge point of this. The executor agent runs all Python code inside a dedicated, isolated sandbox.
Why is that so non-negotiable? I mean, for a system like this to be taken seriously.
Because you're giving the AI keys to your environment, essentially. A sandbox isolates it. It prevents any possibility of malicious code, runaway processes, data leaks, anything. It means the system can experiment and run logic without ever posing a threat to the machine it's running on. It's a massive risk reduction step.
Got it. Okay, so now we have data from the researcher and maybe some process numbers from the executor. But it's all just raw output, right?
Raw output, exactly. It needs to be understood. And that's the cue for the analyzer agent.
So the analyzer is the one that actually does the analysis. It's looking for the patterns, the story in the data.
It's the critical thinking engine. It turns the what into the so what. But, and this is probably my favorite part of the whole architecture, even the analyzer's work isn't trusted blindly.
Oh, this is the good stuff. This is where the reliability comes in.
This is what makes it robust. It goes to the evaluator agent.
Evaluator.
And its job is to check every single output from every other agent. The research it found, the code results, the analysis, even the plan itself.
So it's an internal auditor. It's quality control at every single step.
It's a required quality loop. This is what moves an AI system from, I hope this is right, to this has been verified. It ensures the system doesn't go down a wrong path based on a faulty piece of information early on.
That's huge. But what about institutional knowledge? For a complex project, the system needs to remember what it learned in step 1 to do step 5 correctly.
And that's where the memory agent comes in. Every time a piece of information passes the evaluator's check, it can be stored by the memory agent. This way, the system builds up a knowledge base over time. No need to research the same thing twice.
So it gets smarter.
Exactly.
Okay, so the final piece. We have the plan, the research, the executed code, the analysis, the memory, all checked and verified. How does this turn into something I can actually read?
That is the job of the grand finale agent, the result combiner.
Combiner.
It just merges all of those verified pieces into one polished, structured, final answer that it sends back to you, the user. It wraps it all up with a bow.
I have to ask, though, isn't having, 7 different agents a bit of an overcomplication? Doesn't that just create more points of failure?
It's a great question. And it would be a problem if they were all generalist. But because each one is so narrow, one only researches, one only evaluates, they're actually way easier to build and debug. The complexity is managed by the flow, not the individual parts.
I see. So the modularity is actually what makes it robust. You know exactly where something went wrong if it does.
Precisely.
So let's ground this for a second. The tech stack that makes this all possible, the sources mentioned the front end is built in React, which makes for that nice clean interface, and the back end is on FastAPI.
Yeah, and those are smart choices. FastAPI is built for speed and performance. And an interesting little detail from the demo notes is that it's hosted on Render, which means sometimes, if it's been idle, the backend might take 2 or 3 minutes to wake up.
That little detail really brings this sophisticated system back down to earth, doesn't it? The realities of deployment.
It does.
But okay, let's get to the so what. Why should you, our listener, care about this? What problem is this solving?
The biggest one is context switching. Think about it. For a research task, you're usually jumping between your browser, a spreadsheet, maybe a code editor, a Word doc. It's fragmented. AutoOps does all of that in one process.
So let's talk capabilities. Performing long-form research is a huge one. For an analyst, that could be days of work.
A huge time saver. And not just research, but the ability to safely execute Python code. So if you need to clean that data or run a specific model on it, it can do that too.
And it generates the plan for you. For a lot of people, just structuring a project is the hardest part. It does the outline.
Right. And with the memory agent, it gets better and more efficient over time. So for developers, for students, for researchers, for business analysts, this automates huge chunks of their daily workload. It lets them focus on the bigger picture.
So it's not just about saving time on one task. It's about delegating the entire complex process.
It is. The seamlessness is the key. From one single input from you, Gemini Flash provides the strategy, the coordinator directs the traffic, the specialists do their jobs, the evaluator checks the work, and the combiner hands you the finished product.
The ability to just delegate that entire chain of thought and execution. It really brings us to our final thought for you to chew on. If today we can fully hand off these complex, multi-stage tasks, research, planning, coding, analysis, to a coordinated AI system like this, what kind of roles are left for us? Are we just supposed to focus on asking better, bigger, more interesting questions and leave the how to the machines?
The focus really shifts from the mechanics of the work to the strategy behind the questions you ask. Something to think about.
Thanks for joining us on this deep dive. We'll see you next time.